These are the answers to the CCEA A2 Chemistry Fact File 5.3 Volumetric Analysis. So these are the titrations. First question. 25 cubic centimetres of hydrogen peroxide solution were added to excess acidified potassium iodide solution, and the resulting solution made up to 500 cubic centimetres. Okay. And 25 cubic centimetres of the dilute solution reacted with 36.4 cubic centimetres of sodium thiosulfate of concentration 0.1 moles per dm cubed. Which one of the following is the concentration of the undiluted hydrogen peroxide? Well, I can tell you that the answer is C, 1.46 moles per dm cubed, but how do we get there? So, first thing we can do is we have the information in the question about the moles of thiosulfate. So, number of moles of the thiosulfate is 36.4 times 0.1 divided by 1,000, which is given as 3.64 by 10 to the minus 3. So that's the number of moles of sodium thiosulfate. The next thing we can do is to work out then the number of moles of hydrogen peroxide in 25 cubic centimetres. So we're taking that number of moles of the thiosulfate and dividing it by 2 because it's a 2-to-1 ratio. So 1.82 by 10 to the minus 3 moles then of the hydrogen peroxide. Next, we're looking at the concentration of the diluted hydrogen peroxide. So we're multiplying that number by 40 because that was in up here in 25 cubic centimetres. So to get that up to 1 litre, we multiply it by 40, and that's 0.0728 mole per dm cubed then. So then the dilution factor was 20, so we're going from 25 to 500, so the original solution 0.0728 by 20, which is 1.456 moles per dm cubed, which is answer C. A lot of work for 1 mark. The same with this one. So 25 cubic centimetres of potassium iodate 5 solution were added to excess potassium iodide solution dissolved in sulfuric acid. The iodine liberated required 30 cubic centimetres of 0.5 molar thiosulfate solution. Which of the following is the concentration of the potassium iodate solution? Well, again, the answer I'm going to tell you from the beginning is 0.01 moles per litre. Now, working that out, we take the information from the question. So we have 30 cubic centimetres of 0.05 thiosulfate. N equals mv over 1,000. So plug those in. We get 1.5 by 10 to the minus 3 moles. The ratio for this reaction is 1 mole of the iodate with 6 moles of the thiosulfate. Therefore, the number of moles of the iodate in 25 cubic centimetres is this number that we've worked out already here, divided by 6, which gives us 2.5 by 10 to the minus 4 moles. So the concentration then of the iodate, 2.5 by 10 to the minus 4 times 40 to get us up to 1 litre, which is 0.01 moles per litre, which is A. Okay. The next one is a wee bit different. We've got iron 2 oxalate completely oxidized by acidified potassium manganate 7. The iron 2 ion is oxidized to iron 3. So we've got the equations here, iron 2 to iron 3. We've got the oxalate completely oxidized to carbon dioxide. And then we have the manganate 7 here going to manganese 2. So what you have to do here is, to begin with, you're going to add these, it says write the equation for the reaction of acidified manganate 7 with iron 2 oxalate. So it's a bit of a faff really. The first thing you have to do is add these two equations together. Okay, so we have the iron oxalate in there. So that's just a 1-to-1 ratio for these two. So it's Fe2 C2O4 gives you Fe3 plus 2 CO2 plus 3 electrons. Now, in here, 3 electrons, and in this, we have 5 electrons. So what we have to do is multiply the top equation by 5 and the bottom one by 3. So that then gives us for this iron oxalate thing 5 Fe2C2O4 giving 5 Fe3 plus 10 CO2 and 15 electrons. And for the bottom one, for the manganate, 3MnO4 minus 24H plus and 15 electrons gives us 3 of the manganese 2 and 12 water. Now you'll notice that in both of these there are 15 electrons, and one's on the right hand side, one's on the left hand side, so we can cancel those out before we go any further adding them together. And then when we do add them together, it becomes on the left 5 Fe2C2O4 plus 3MnO4 minus plus 24H plus, and on the right hand side we have 3Mn2 plus 5 Fe3 plus 10 CO2 plus 12 H2O. Next one, oxalic acid is used to remove iron stains because iron dissolves to form iron 2 oxalate. Calculate the mass of iron in milligrams dissolved in a 100 cubic centimetre solution if 20 cubic centimetres of the iron oxalate solution react with 18.2 of 0.002 molar potassium manganate 7 solution. Okay, so what can we work out from the question? Well, we've got all of the information for the manganate 7, so we plug that in to find out the number of moles of it. So 18.2 by 0.002 divided by 1,000, and that gives us 3.64 by 10 to the minus 5 moles. Now, we know that the iron and manganese react in a ratio of 5 moles of iron to 3 moles of manganese. So we can work out the number of moles of the iron oxalate in that 20 cubic centimetres. So 3.64 by 10 to the minus 5, we're dividing by 3 and multiplying by 5, and that's giving us 6.07 by 10 to the minus 5 moles. Now, the next bit we need to do is, I've lost control of my page. There we go. The next bit is the number of moles of the iron oxalate, let's do it again, in 100 cubic centimetres. And then we're just, because we're going from 20 to 100, we're multiplying by 5, and that is giving us 3.033 by 10 to the minus 4. So then in milligrams, 3.03 by 10 to the minus 4, we're multiplying that by 56 to give us, well, 56 is the mass of iron, and then by 1,000 to give us milligrams, so that is 169.9 milligrams, or you could round it up to 170 milligrams. Okay, number 5, acidified dichromate 6 ions can be used to determine the concentration of iron 2 ions. The half equations for the reaction are, so we've got Cr2O72 minus 14 hydrogen ions, 6 electrons gives you 2 Cr3 plus and 7 H2O, and then for iron Fe2 plus gives you Fe3 plus plus an electron. So it asks you to write a balanced equation, ionic equation. So you notice here there are 6 electrons but only 1, so we're multiplying the bottom equation, the iron one, by 6, and that gives us Cr2O72 minus plus 14H plus 6 Fe2 plus gives you 2 Cr3 plus 6 Fe3 plus and 7 H2O. I've got nice wee back titration about iron tablets. So 5 iron tablets containing iron 2 sulfate were dissolved in acid and the solution made up to 250 in a volumetric flask. Then 25 of this solution required 23.5 cubic centimetres of 0.01 molar sodium dichromate for complete oxidation. Calculate the mass of iron 2 sulfate in 1 iron tablet. So We start with what we can do from the question, which is the moles of the dichromate, so 23.5 times 0.01 divided by 1,000, which gives us 2.35 by 10 to the minus 4 moles. And then from the balanced equations up here, we know that it's 1 to 6 for the ratio. So we're going to take that number to find the moles of iron in 25 cubic centimetres. We're going to take the 2.35 by 10 to the minus 4 multiplied by 6, which gives us 1.41 by 10 to the minus 3 moles. Now that's in 25. So in 250, we're just multiplying that by 10. So it's 0.0141. Now the mass of iron sulfate in 250 then is 0.141 times 152. That's the formula mass, which is 2.143. So then in one tablet, there were 5 tablets to begin with in the question. It's 2.143 divided by 5, which is 0.429 grams. Now in the mark scheme it says there -1 per error and -1 if there's no mass unit. So just be careful with those, folks. Final question, the percentage of calcium carbonate present in eggshells can be found by back titration using excess hydrochloric acid and standard sodium hydroxide solution. So 1.12 grams of an eggshell were reacted with 20 cubic centimetres of 2 molar hydrochloric acid, and the solution formed made up to 250 in a volumetric flask. 25 of this solution completely reacted with 18.6 cubic centimetres of 0.1 molar sodium hydroxide. So start with what you know, which is the sodium hydroxide. So 0.1 times 18.6 divided by 1,000 gives us the number of moles, which is 1.86 by 10 to the minus 3. Now, sodium hydroxide, hydrochloric acid react in a 1-to-1 ratio, so the number of moles of HCl remaining in that 25 cubic centimetres at the beginning was 1.86 by 10 to the minus 3 moles. And then, so the number of moles of hydrochloric acid in 250 cubic centimetres, we're just multiplying that by 10, so it's 0.0186 moles. Now, to find the initial moles of hydrochloric acid added, we're doing the 20 of 2 molar. So N equals NV over 1,000, 20 times 2 over 1,000 is 0.04 moles. So we know then that the number of moles of hydrochloric acid that reacted with the calcium carbonate is the 0.04. Take away 0.0186, which gives us 0.0214 moles. So then the mass of the calcium carbonate, we've got this 0.0107 that we just worked out. The formula mass is 100, so that gives us 1.07 grams. And the question asks for the percentage of the calcium carbonate in the eggshells. So we found 1.07. The question said 1.12 grams times 100, 95.5%. So thanks for watching this.